Hi, I'm Emily from emilylearning.com, and in this video here, I'll be going through paper 2 of the May-June 2024 Cambridge International A-Level Math paper. Let's take a look at the first question. So in the first question, we are given a curve has an equation of this: y equals to 2 tangent x minus 5 sine x for x in between 0 to pi over 2 inclusive of 0 but excluding pi over 2. You are asked to find the x coordinates of the stationary points of the curve and give your answer correct to 3 significant figures. So we do know that at stationary point, dy dx is equals to 0. So this is what we are going to do first. So we are going to find what is dy dx. So we are going to differentiate the expression for y. So differentiate 2 tangent, we get 2 secant square x. Differentiate 5 sine x, we get 5 cosine x. Okay. So next, at stationary point, okay, we know that dy dx is equals to 0. So we have 2 secant squared x minus 5 cosine x is equals to 0. Okay, now we know that secant square is the secant is the same as 1 over cosine. So let me rewrite this as 2 over cosine square x minus 5 cosine x is equals to 0. Okay, so I will multiply all terms by cosine square x, which give me 2 minus 5 cosine cube x equals to 0. In other words, cosine cube x is equals to 2/5, and cosine x is equals to 2/5 to the power of 1/3, or cube root of 2/5. Next, because I know that x is in between 0 to pi over 2, which is effectively in the first quadrant. Okay, so I only need to take the angle in the first quadrant. So to find x, I will simply take cosine inverse 2/5 to the power of 1/3. Okay, and because of what is given, the range of x is between 0 to pi over 2, so it is in radian. So we need to make sure that our calculator is in radian mode. Okay. Okay, so by typing this into a calculator, I obtained a value of 0.742 radians when rounded off to 3 significant figure. Okay, so this is the x coordinate of the stationary point. Let's move on to question 2. A curve has this equation: x squared ln y plus y squared plus 4x equals to 9. Find the gradient of the curve at 2, 1. So we need to find the value of dy dx when x is equals to 2 and y equals to 1. So what do we need to do? We first need to differentiate this. And because this curve, the equation of this curve is in terms of both x and y, and we cannot make we cannot make y the subject easily. So therefore, we are going to use implicit differentiation. So let's do an implicit differentiation on x squared ln y plus y squared plus 4x equals to 9. So x squared and ln y are like two terms, so we need to use product rule. So I'll first keep x squared and I differentiate ln y, which gives me 1y dy dx. Next, I will keep ln y and differentiate x squared, which gives me 2x. Next, I'll differentiate y squared, which gives me 2y dy dx. So essentially, if you are differentiating any variable that is not x, okay, you will need to put in the d variable over dx. Okay. Next, differentiate 4x gives me 4. Differentiate 9 gives me 0. Okay. So this is what I have now. So I can actually simplify it if I want to, although you can just immediately sub in your x equals to 2 and y equals to 1 in as well. Okay. So let me sub in x equals to 2, y equals to 1 into this expression here. So I'll have x is 2, so it's 2 squared over 1 dy dx, plus 2 times 2 is 4, then ln 1, plus y is 1, so 2 times 1 is 2 dy dx, plus 4 equals to 0. Take note, ln 1 is 0. Okay, so you have 4 dy dx plus 2 dy dx equals to negative 4. So I know I have 6 dy dx equals to negative 4. dy dx is equals to negative 2/3. So therefore my gradient, okay, at the point 2, 1 is negative 2/3. Let's move on to question 3. In question 3, you're asked to sketch on the same diagram the graphs of this and this. Okay, and if we move on to part B, we know that we need to solve the inequality. To solve the inequality, right, we do need to know the point of intersection. Okay, so let's first look at how to sketch. Let's sketch this first. Y equals to 5 minus x. So I know that, okay, the y-intercept is at 5. Okay, and then to find the x-intercept when y is 0, x is 5, right? Okay, so therefore this is my graph. Oops, not too nice. Maybe let me label this later. Okay, so here is 5, here is 5, and this is y equals to 5 minus x. So the way to draw a straight line, right, what you do is you find the x-intercept and the y-intercept. So you know for this one, when x is 0, y is 5. Okay, and when y is 0, x is 5. So therefore we have these 2 points here. Next, let's take a look at this one here. Okay, so I have y equals to mod 3x minus 8. Okay, and this type of graph, so when here is linear, it typically looks like a V shape, right? So what do? Well, we can first start off by drawing y equals to 3x minus 8, right? So for y equals to 3x minus 8, the y-intercept is at 8. Sorry, it's at minus 8. And the x-intercept, okay, that means when y is 0, so 3x minus 8 is 0, x is equals to 8 over 3, right? So, or equals to 2 and 2/3. So this is where it is. So let me first draw it in dotted lines. Okay, so this one is y equals to 3x minus 8. But what do we do when we mod? When we mod something, it no longer have any negative value. So the y will not have any negative values. So we need to reflect this portion here that is below the x-axis, okay, about the x-axis. So it will look something like this, right? Correct? So we know that we will have a graph that looks like this. Okay. So because I reflect this line here upwards, here's minus 8. When I reflect it above, here it becomes positive 8, right? I know that this is 2 and 2/3. Okay. I also need this point of intersection and this point of intersection. Okay, but they did not ask for it, so I'll do it in part B. Okay, so this is the answer for part A. So we have y equals to mod 3x minus 8 and y equals to 5 minus x. Remember to label these two graphs. Now you're asked to solve the inequality where mod 3x minus 8 is lesser than 5 minus x. So if you have to take a look at it, right, at which point, right, is mod 3x minus 8 lesser than 5 minus x? Well, it is at this part, right, because it's this green line or this green graph is below the blue graph, okay, from here to here. Okay, so if this point, if the x coordinate here is a and this is b, I know that my answer will be x is in between a and b, because the green graph is below the blue graph from x equals to a to x equals to b. Okay, so how do I find a and b? Well, I need to solve for this equation, right? So let's first solve. So let's first solve this one. Okay, there are a few ways. I'm going to show them to you. Okay, so if you want to use the graphical method, you can do this. Okay, equals to 5 minus x. Okay, then if to remove this mod, you will put plus minus. So you have this. So this is the plus one, this is the minus one. Okay, so you have 4x equals to 13, x equals to 13 over 4. Then you have negative 3x plus x, so it's negative 2x equals to 5 minus, because minus minus becomes plus, so it is plus 8, so I bring over is minus 8. So 5 minus 8 is minus 3. So x is equals to 3 over 2. So I know that a is 3 over 2 and b is 13 over 4. So therefore, from sketch, I know that x is in between 3 over 2 and 13 over 4. Okay, so this is one way to solve it. Find the point of intersection. Then once you know the point of intersection, right, you solve for it, right? Okay, so this is the portion. Okay, or you can simply use the inequality method. So you have mod 3x minus 8 is lesser than 5 minus x. So how do you remove this mod? Okay, remember, if it is lesser than, so if you have mod a lesser than b, so a is in between negative b and b. If you have mod a greater than b, then to remove this mod, you have a greater than b or a lesser than negative b. Okay, you can make use of these formulas here. Okay, so I'm going to make use of this formula, okay, as an alternative method. So this is method 2. So we are just going to use this method. So because it's lesser than, so I know that 3x minus 8 is in between negative 5 minus x and positive 5 minus x, right? Okay, when it's in between, you can switch it into n. So I will solve minus 5 plus 8 lesser than 3x minus 8 and 3x minus 8 lesser than 5 minus x. Okay, so I will have 2x then 3. So x is greater than 3 over 2. Then here I have 4x lesser than 13. X is lesser than 13 over 4. Because it's an n, I need to take intersection. So what I'll need to do is, I know that x here is 3 over 2. Here is 13 over 4. So x is greater than 3 over 2. So I'll draw it here. X is lesser than 13 over 4, which is here. Okay, so where's the intersection? Well, the intersection is here, right? So therefore, we have x is in between 3 over 2 and 13 over 4. And that is the solution for part B. Next, we are asked, hence determine the largest integer n satisfying the inequality of this. So because it's a hence, we need to make use of what we have done previously. So if you to compare this with this, what do you notice? Basically, the x is replaced by e to the power of 0.1 n, right? So we will replace x in part B with e to the power of 0.1 n. So since x is in between 3 over 2 and 13 over 4, that means e to the power of 0.1 n is in between 3 over 2 and 13 over 4. Okay? Now let's do, so how do, I'm going to ln everything. So I'm going to ln 3 over 2. I'm going to ln e to the power of 0.1 n. I'm going to ln 13 over 4. Okay? Now, ln e to the power 0.1 n is effectively 0.1 n. And that is why we ln it, because we do not want the power. We want to bring the power down. Okay, I'm going to type these into the calculator because I'm basically looking for the integer of the largest integer of n, right? So I do not need exact values. So this is 0.40546. Okay, then let me do the other portion. 1.17865. Then I'm going to divide everything by 0.1. So this one will give me 11.7865. Okay. Here will give me 4.0546. So based on this, okay, I know that the largest integer value of n is basically 11 because n can be up to 11.7865 and the largest integer that is up to 11.7865 is 11. Now let's take a look at question 4. Question 4 is a proving identity question. So in question 4, you're asked to show that 3 tangent 2 theta plus tangent theta plus 45 degree is equals to this. If you're to take a look at this, you're going to change 2 theta to finally just theta. Everything here is in terms of theta. Theta plus 45 degree, you're going to change it to also theta. So let's take a look at our list of identities and see which one will be the ones we are going to use. So let's refer to our formula booklet MF19. Okay, and this is where the formulas are. So we know that we need to change tangent 2 theta to theta. So it's like we are going to use the double angle formula here. We want to change tangent theta plus 45 degrees to tangent theta. So we also use this formula here. Alright. Okay. So let's do it. So we start off with the left hand side, which is 3 tangent 2 theta plus tangent theta plus 45 degrees. So I'm going to change this. Okay. This 2 theta. So here's 2a, right? So now it's 2 theta. I'm going to change it to theta. So I end up having 2 tangent theta over 1 minus tangent squared theta. Okay, and because it is 3 tangent 2 theta, if you times a 3 here, it will give me 6 tangent theta over 1 minus tangent squared theta. Okay, so let's write it there. So let's just write it directly to save time. Okay, so 1 minus tangent squared theta. Next, I'm going to do the same to this. So now I have tangent theta plus 45 degrees. So here is tangent theta plus 45 degrees, right? So I'm going to use the plus one. And A will be theta, B will be 45 degrees. So it will be tangent theta. So because here is plus, plus is on top, here also be plus tangent 45 degrees over 1, because here is plus, plus is on top, so minus is on top now, so it's 1 minus tangent theta tangent 45 degrees. Okay, so let's change that. Let's do that. So it's equals to tangent, so I'm going to simply just copy this, tangent theta plus tangent 45 degree over 1 minus tangent theta tangent 45 degrees. And what do we know about tangent 45 degrees? You can type it into your calculator. Tangent 45 degrees is 1. Okay. So this is 1. So it's tangent theta plus 1 over 1 minus tangent theta. So now I only have a single fraction, right? In other words, I need to combine these into a single fraction. Okay. I know that 1 minus tangent square theta is equals to, you can factorize it into 1 plus tangent theta 1 minus tangent theta, right? Recall, a square minus b square equals to a plus b, a minus b. So a is your 1, b is your tangent theta. So therefore I can rewrite it as this. So why do I want this? It's because I want here to become 1 minus tangent square theta, right? So to do that, I already have the 1 minus tangent theta. I just need to multiply this fraction by 1 plus tangent theta over 1 plus tangent theta. Okay? Okay. So let me just copy this. So once I do that, I know that they both have the same denominator, which is 1 minus tangent square theta. So this is 1 minus tangent square theta. If I have 1 minus tangent theta times 1 plus tangent theta, based on this, I get 1 minus tangent square theta. Okay? So now I can combine this tangent theta plus 1 times 1 plus tangent theta, or it's basically just tangent theta plus 1 squared. Okay, expand this, I'll get tangent squared theta plus 2 tangent theta plus 1. Okay, so make it the same as what we have here. So I'll first write tangent squared theta. Okay, then next I will add out the tangent theta. So I have 6 tangent theta plus 2 tangent theta, which gives me 8 tangent theta. And finally plus 1 over 1 minus tangent squared theta, which is equals to my right hand side. Okay, so I have proven this already. Because they asked me to show, I'll just write shown. Okay, now that I'm done with this, they asked me to hence solve the equation 3 tangent 2 theta plus tangent theta plus 45 degree equals to 4. Okay, so this looks so familiar, right? It's the same as this one here. Okay, and so what we need to do is basically to change this into this, right? Because they are equal. Okay, then I'm going to equate it to 4, because you cannot have tangent 2 theta and tangent theta plus 45 degrees. You cannot solve them at the same time. So therefore you must change every tangent to a tangent theta in order to be able to solve them. Okay, so let's do it. So I have 3 tangent 2 theta plus tangent theta plus 45 degrees equals to 4 for theta in between to 0 degrees and 180 degrees. So I know that I only need to look at the first and the second quadrant, right? Okay, now I know that this is equals to this. So I'm going to rewrite it as, so this 3 tangent 2 theta plus 45 degree is the same as tangent squared theta plus 8 tangent theta plus 1 over 1 minus tangent squared theta. Okay, now I'm just going to do a cross multiplication. Okay, if you want, you can say from A. Okay, or you don't need to write this. Okay, so now let's just do a cross multiplication. Okay, put all the tangents squared together. I have 5 tangent squared theta plus 8 tangent theta minus 3 equals to 0. So after this, I will need to do what's that? I'll need to factorize, right? Okay, am I able to factorize? Maybe not. So maybe what I'll do is I will use tangent theta equals to, so this is like your 5y squared plus 8y minus 3 equals to 0, right? So you will use the formula to find what is y. Okay, so the y is basically your tangent theta. So it's minus 8 plus minus b squared minus 4ac over 2 times 5. Okay. Okay, then let me just evaluate them. Okay, so remember this is in degree. So just now we just changed our calculator to radian mode, right? Now we need to make sure that it's in degree mode. So theta will be equals to tangent inverse . Okay, so this one here, right, if you type it into your calculator, you probably get a negative value. So what I'll do is, okay, I will do tangent theta equals to this. So I know that for this one, theta is in the second quadrant, but let's first find the basic acute angle of theta based on this. So I'll ignore the negative sign. Then, because this theta is in the second quadrant, right, ASTC, because it's negative and we know that we only need to consider these two quadrants, so I'm looking at the second quadrant. So theta is 180 degree minus this value here. Okay. Next, let me do tangent theta equals to 0.31355. And because this is positive, I know I need to look at the first quadrant. So basically, I'll just take tangent inverse 0.31355. It will give me the angle in the first quadrant. Okay, so once I've done this, I know these are my answers. So I have two answers. So theta is 17.4 degree or 117.6 degree. Okay. Now let's move on to question 5. A curve has this equation. The curve has exactly one stationary point at P. Okay, so that means when you find dy dx, you only and let dy dx be equals to 0, there's only one solution. Find dy dx and hence show that the coordinate of P satisfy this equation. So let's first go to find dy dx. Okay, I will use quotient rule. You can also use product rule. So for quotient rule, I'll first differentiate the numerator. So differentiate 1 plus e to the power of 2x will give me 2e to the power of 2x. Then multiply by denominator, minus differentiate the denominator, which gives me 3. Then just copy the numerator over the square of the denominator. Okay, so let me simplify. So I have 2e to the power of 2x plus 6x e to the power of 2x minus 3 minus 3e to the power of 2x over 1 plus 3x squared. Okay, let's go. So we have 6x e to the power of 2x minus e to the power of 2x minus 3 over 1 plus 3x squared. Okay, so at stationary point, right, we know that dy dx is equals to 0. So this whole thing is equals to 0. Okay, and with that, I do a cross multiplication. This is gone, so I'll be left with 6x e to the power of 2x minus e to the power of 2x minus 3 is 0. Okay. Okay, so I know that the x coordinate of the stationary point will satisfy this equation. Okay, so let me say, so x coordinate of P satisfies equation 1, right? Okay, now I need to find x, right? So let me make x the subject. Okay, so what I'll do is I will put x here and then move everything else to the next side. Okay, now I will divide everything by 6 e to the power of 2x. Okay, so I will get this one, it becomes half, right? Then 1 over e to the power of 2x is the same as e to the power of minus 2x. Okay, rewrite it to be the same as the question. So it's 1 over 6 plus half e to the power of minus 2x. So I have shown. Okay, so I show that the x coordinate of P satisfy this equation, because I can rewrite this into this. Okay, if you want, you can write x here also. Next, we are asked to show by calculation that the x coordinate of P lies between 0.35 and 0.45. Okay, so what I'll do is I will let y, so what I'll do is I'll have x equals to 1 over 6 plus half e to the power of minus 2x. Then let me call it this way. So I will let maybe fx be equals to this, x minus 1 over 6 minus half e to the power of minus 2x, right? So I know that f 0.35, let me find out what is f 0.35. That means I'm going to sub in 0.35 into this one. So this one is the numerical methods. Okay, and it will give me around negative so this one gives me negative 0.282, right? Next, I have f 0.45. What does it give me? So I'm going to sub in 0.45 into this here. It is positive. Okay, so if I were to sketch this, right, I know that roughly this curve looks like this, right? At 0.35, x equals to 0.35, it is here. At x equals to 0.45, it is here. So I know that the root, so if I want to solve for x minus 1 over 6 minus half e to the power of minus 2x, I need to find what is the point A, right, which is the x-intercept. So because f 0.35 is negative, f 0.45 is positive, I know that A, or the root, or the x-coordinate is in between these two, 0.35 and 0.45. Okay, so I'll write since okay, so we need to talk about this. Talk about f 0.35 is lesser than 0, f 0.45 is greater than 0. So to find fx equals to 0, it must, the x occur between 0.3, x equals to 0.35 and 0.45. Alright. Moving on to part C, use an iterative formula based on equation in part A. So they want us to use this formula. Find the x-coordinate of P correct to 3 significant figures. Give the result of each iteration to 5 significant figures. So what we need to do is we need to keep iterating, okay, until when we round it off to 3 significant figures, we get that answer. Alright? So let's use the iterative formula, okay, which is x n plus 1 equals to fxn. So we will let fxn it be equals to 1 over 6 plus half e to the power of minus 2 xn. So xn plus 1 equals to this, right? Okay, so I'll let x1 be equals to maybe 0.35. Actually, I'll make it 0.45 because 0.45 is closer to 0. Okay, so x2 is equals to 1 over 6 plus half e to the power of negative 2 times 0.45. Right? So let me type this into the calculator. So I get 0.36995. Okay, very different from the first one. So let me continue. X3. So I get 0.40524. Okay, 5 decimal place or 5 significant figures. Let's go on to x4. So I won't stop here because if I round it off to 3 significant figure, this is 0.370. This one is 0.405. So they are not similar, so I cannot stop. So I need to continue. Okay, continue. Okay, so here is round off is 0.390. Here is 0.397. Okay, so maybe I'll do one more time. Okay, so you can continue. Okay, so I'm going to continue. I'm not going to write so many anymore. So if I have to round this off to three significant figures, it's 0.394. If I have to round this off to three significant figure, is 0.394. Is three significant, they are the same. So therefore, I can conclude that x is equals to 0.394 when rounded off to three significant figure. To check, I can sub 0.3945, so I can find what is f using this equation here. Okay, I'll use f 0.3945 and find out what is f 0.3935, right? See whether I have one positive and one negative. Okay, so let me do that. So this one is positive. This is negative. So because I know that at 0.03935, the curve is negative. At 0.3945, it is positive. Therefore, 0.394 could be the answer or is the solution to this equation when rounded off to 3 significant figure. Okay, so that's how I get 0.394 as the answer. Let's take a look at question 6. So question 6 is an application of integration question. So let's take a look at part A. So we are given this diagram here which shows the curve y equals to square root sine 2x plus sine squared 2x. So this is y equals to square root of sine 2x plus sine squared 2x for x in between 0 to pi over 6. The shaded region is bounded by this curve here, and the straight lines x equals to pi over 6, which is here, and y equals to 0, which is the x-axis. Okay, you're asked to use the trapezium rule with 2 intervals to find an approximation to the area of the region. So 2 intervals, that means I just cut it into 2. So here is pi over 12. Okay, and the height, and this here, okay, the interval between each interval is pi over 12. Okay, to find the approximation of the area of the shaded region, give your answer corrected to 2 significant figures. So we can find area. So we know that if I were to use the trapezium rule, the area will be approximately h over 2, then f at 0 plus f at pi over 6 plus twice of the x that are in the middle, so it's pi over 12. Okay, f pi over 12. This is the formula. Or you can also find the area of this here, the trapeziums. In this case, this one is a triangle because at x equals to 0, y is 0. Okay, but I'll just use the formula. So I know that h, the interval, is equals to pi over 12, right? Then I will also let fx be equals to this one, square root of sine 2x plus sine squared 2x. So I'll find f0 is 0, type it into the calculator, find f pi over 12, which gives me 0.8660254, and f pi over 6 gives me 1.271229. Okay, so now subbing all these values into the formula for trapezium rule, okay, I'll have pi over 12 over 2, then plus 0 plus 1.271229 plus twice of 0.8660254. Okay, then type the whole thing into the calculator. You should get 0.39 units square when rounded off to 2 significant figure. Next, let's move on to part B. The shaded region is rotated about the x-axis. So we are going to rotate this about the x-axis and look at what is the volume generated. So whenever you are rotating about the x-axis, the formula is pi y square dx. Okay, and because it is from x equals to 0 to x equals to pi over 6, we will put in the limits. So y is equals to square root of sine 2x plus sine squared 2x. So y squared will be without the square root. So y squared is sine 2x plus sine squared 2x. Okay, we can integrate sine directly, but we cannot integrate sine squared directly. So we need to make use of the identity. Okay, so it is here. We need to change sine squared into something without a square. So we'll use the identity cosine 2a equals to 1 minus 2 sine squared a. Alright. Okay, so I have cosine 2a equals to 1 minus 2 sine squared a. But for this case, we have x, right? So let me take a look. So we have sine squared 2x, right? So I have sine squared 2x. So here will be cosine 4x because it's double angle. If here is 2x, here will be 4x. If here is 3x, here will be 6x, and so on. So I'll make sine squared 2x the subject. So sine squared 2x equals 2 sine squared 2x is equals to 1 minus cosine 4x. So sine squared 2x is equals to half minus half cosine 4x. Okay, so I'm going to put this in. Okay, with that, we can do our integration. So integrate sine 2x will give us negative cosine 2x over 2. Integrate half will give me half x. Okay, then integrate minus half cosine 4x will give me 1 over 2 times 4, so that means 1 over 8 sine 4x. Okay, now let's sub in the values. So I'll first sub in x equals to pi over 6. So I have cosine pi over 3 now, because 2 times pi over 6 is pi over 3 over 2, plus half times pi over 6 is pi over 12, minus 1 over 8 sine 4 pi over 6. Then minus cosine 0 is 1, so it's negative. So here's 1, so it's negative 1 over 2. Then sub in x equals to 0, half times 0 is 0. Then next I have sine 0, sine 0 is 0. So this is what I have here. So next, now that I have this, I need to simplify. So cosine pi over 3 is half. Half over 2 gives me negative 1/4. Then I have pi over 12 minus 1 over 8 sine 2 pi over 3 plus half. Okay, sine 2 pi over 3, so it's in the second quadrant. Second quadrant sign is positive. Okay, and the basic angle for sine 2 pi over 3 is sine pi over 3, right? And since the first and the second quadrant are positive, sine pi over 3 is the same as sine 2 pi over 3, which is equal to root 3 over 2. Okay, minus half plus half is, minus 1/4 plus half is positive 1/4. This one plus pi over 2 minus 1 over 8 root 3 over 2. Okay, if I were to multiply these together, is root 3 over 16. So maybe let me rewrite it as root 3 over 16 instead. Okay, so I'll get 1/4 pi plus 1 over 12 pi squared minus 1 over pi over 16 times root 3 units cubed as the volume. So this is the answer for part B. Alright, let's take a look at question 7. So in question 7, you are given a polynomial px is defined by px equals to 9x cubed plus 6x squared plus 12x plus k, where k is a constant. And you are asked to find the quotient where px is divided by 3x plus 2 and show that the remainder is k plus 8. So let's do a long division. So I have 9x cubed plus 6x squared plus 12x plus k, and I'm going to divide by 3x plus 2. So I'm going to compare 3x with 9x cubed. So I need 3x squared multiplied by 3x to make 9x cubed. So I'll do that. Then 3x squared times 2 will give me 6x squared. Then I subtract it. 9x cubed minus 9x cubed is 0. 6x squared minus 6x squared is 0. Then I bring down 12x. Okay, so what times 3x will give me 0? Well, 0 times 3x will give me 0, right? Then I'll minus, and I'll be left with 12x, and I'll bring down my k. Okay, so next, what times 12x will give, what times 3x will give me 12x? Well, it is 4, right? 4 times 3x will give me 12x. Then plus 4 times 2 will give me 8. Minus, it gives me k minus 8. So here, this is the quotient. And this is the remainder. So based on this, let's answer the question. Quotient is equals to 3x squared plus 4. Remainder is k minus 8. Okay, I'm shown that the remainder is k minus 8. Next, it is given that the integration of px over 3x plus 2 dx is a plus ln 64, where a is an integer. Find the values of a and k. So we are asked to integrate this px over 3x plus 2 dx. Okay, is equals to a plus ln 64. So I know that px is this. Okay, and if I know what it is divided by, the quotient and the remainder, I can also write px as the quotient times this 3x plus 4 plus 3x plus 2 plus the remainder k minus 8. Right, I'm going to write it as this because I do want to cancel away this 3x plus 2. So I will write it as 6, 1, px is 3x squared plus 4, 3x plus 2 plus k minus 8 over 3x plus 2 dx. Okay, let's continue. I'm going to split this into two fractions, 3x squared plus 4. Okay, then let's cancel away this. So I only have 3x squared plus 4 here. Okay, I want this. So remember that k minus 8 is essentially a constant, like 4, 5, 6. So now we can integrate. So integrate 3x squared will give me 3x cubed over 3, okay, which is effectively x cubed. Integrate 4 will give me 4x. Integrate k minus 8, remember k minus 8 is a constant, over 3x plus 2 will give me k minus 8 over 3, okay, ln 3x plus 2, okay. Then I need to sub in 6 and 1. So I'll sub in x equals to 3, x equals to 6 into x cubed, so that means it is 6 to the power of 3, which is 216. 4 times 6 will give me 24, plus k minus 8 over 3 ln 3x plus 2, and when x is 6, I basically has ln 20. Then I will minus, now I sub in x equals to 1, so 1 cubed is 1. 4x when x is 1 is 4. Then plus k minus 8 over 3 ln 5. So I'll take this and this, I will simplify them. Okay, so 216 plus 24 minus 5 will give me 235. Then here I have k over 8 ln 20 minus k over 8, k minus 8 over 3 ln 5. Okay, so let's combine this. So recall, if you have ln A minus ln B, it can be simplified into ln A over B, right? Okay, why do I want this? Because in the end, I want to have ln 64. Did I make a mistake? 3, 6, 18. 18 minus 20. Okay. 8, 6, 3, 18. 20, 3, 2, 5. Okay, let's continue. So I have this 235 plus k over 83 ln, this is 16, right? Sorry, 20 over 5, so it's ln 4. Okay, what do I have here? I'm told that this is a plus ln 64, right? Okay, so I do know that there is nothing in front of the ln 6. So if I've a ln a, it will be equal to ln big A to the power of a, right? So what I'll do is I will write this as 235 plus ln 4 to the power of k minus 8 over 3. So I know by comparing a is equals to 235. And by comparing here and here, I know 4 to the power of k minus 8 over 3 is equals to 64. And I know that 64 is 4 cubed, right? So I know that k minus 8 over 3 is equals to 3. So in other words, right, k is equals to 9 plus 8, which is equals to 17. 3 times 3, then you bring over the 8. So therefore, I know that a is equals to 235, while k is equals to 17.